So this is something that some of you told me Mr. Hempton, who was your sub one day, began to explain to you. And so I want to take a few minutes and explain to you about the arithmetic of nuclear reactions. It's pretty simple. It's much simpler than actually doing nuclear chemistry. Let me just increase the view size a little bit here. Go to 150%. And you should have table O out with you at the same time. I have it back here. It's ready to go when we have a need for it. Okay, so you'll need table N actually and O, but you'll see why you need N in just a minute. Use table O to help you out on the masses and the charges of the different atomic particles. A little review. In element notation, what's the number on the top? That would be the mass number. Mass number goes on the top, and the number on the bottom is the atomic number or the nuclear charge. So if the number on the bottom changes, the atomic number changes. And so if the atomic number changes, the element has to change also. So let's write some of this in so that you have it properly here. Put it in bold on the top, the mass number. That's protons plus neutrons. A little review there. Bottom is the atomic number. It's really the nuclear charge. That's why we can put for a beta particle or an electron, we can put a -1 there. It's not really an atomic number for an electron, but the charge of it is -1. So that's the important part here. The number on the bottom changes. What has to also change, and that would be the element has to change. So while this isn't alchemy, we're still changing one element into another because of nuclear changes. So I'm going to show you how this works. The example that I'm going to give you here is beta decay of technetium-99. I want to step away from that for just a second because I can't really write those notations very well without handwriting them. So I want to show you an example of what I mean. If something decays by a beta emission, that means that a beta particle is one of the products. And if you look at table N in your reference table, you'll see that there are a whole bunch of isotopes, including technetium-99 right here, that lists the type of decay it undergoes, beta or alpha, some positrons. And again, if you're having some trouble remembering what those numbers are that belong there, then you can go to table O for that. Table N tells you what kind of decay mode any particular radioisotope undergoes. We're going to ignore half-life for now, although many of you know what a half-life is. We're going to ignore that for now. We're just going to focus on decay mode and nuclide. And so what you would do is you would write the beta particle as one of the products. So I'm going to show you a similar reaction right now. You don't have to write it. Just take a look at it. And it's the reaction of lead-210. So you see lead is 210 and lead is 82. You just looked that up in the periodic table. And if you looked it up, lead-210, I don't know if it's on this. It doesn't appear to be on your list. Lead-210 is a beta emitter also. And so you'd write the beta particle right here. You could write it as an E. You could write with a big beta. But the point is it has to have a 0 on the top because that's how much an electron weighs, and -1, that's the charge. And then you just have to figure out what other numbers go here, and that's just a simple arithmetic thing where you make the arrow an equal sign, and you just do a little algebra. 210 equals blank plus 0, which would be 210. 82 equals blank plus -1. Now be careful, the equal sign is here, so 82 equals 83 plus -1, right? Because 83 minus 1 is 82. Now once you do that, and you have the number here, you're going to have to do a little bit of periodic table looking to find out that atomic number 83 is bismuth. So lead-210 becomes bismuth. This is a transmutation. This is a natural transmutation because this is just what lead-210 does. It decays by beta emission. So similarly, I'm not going to put the 43 on the bottom. You can, but just so that I can write it, we have technetium-99, and that goes to, a beta particle, which has a 0 at the top, and yes, you've got to write the -1 at the bottom. I can write it, but it's going to be off. See, it's not really great. But anyway, a beta, I'll just put an E for now to keep it simple, but you should have the 0 minus 1 right on top of each other. And then, what is left? Well, let's see. All right, then technetium was really 9943. I'll play the game here. And hold on a second here. Okay. 9, 3, technetium. So it's not lined up properly, but you get the idea. So, and then, so you just do that 99 equals 0 plus, well, 99. top. And at the bottom, it's 43 equals -1 plus, and that's 44. And then you look up 44 on the reference table, and you find out that that is ruthenium. So notice that the element's identity changes. That's very different from any regular chemical reaction. If you emit something, it's an emission, like this is considered a beta emitter, technetium-99 is a beta emitter, then the particle is on the product side. It's emitted. It's a product. Beta particle is a product. If it's on the left side, it's called a capture. Not going to see that as often, but it's there. Just add the tops and add the bottoms, and you have plenty of practice coming up on the next page. And that's the main exercise that I want you to be able to do because we're already 30% done with the unit. Notice you follow along always, and you use the bottom number to identify the element when you're done for anything you don't know. So I want you to fill in the missing pieces of these reactions. Some of them I give you everything except for one thing. Like this is pretty straightforward. 32 equals 0 plus 32. 15 equals -1 plus 16, right? 16 plus a -1 is the 15. And so you got to fill in the element. So you got to do that. That's pretty simple. A bunch of them I give you that information. All you have is one thing to spot. But then there are a couple down here, 7 and 9, which have 2 boxes. And the reason they have 2 boxes is because you actually have enough information on table N to fill in one of the boxes from the type of decay. Then it's just a 1-box question. So I made a couple of them, not really more difficult, but at least make you use your reference tables a little bit more. So I'd like you in your groups of 4 to do that right now, and we'll go over it in class. And after that, you're done with 40% of the unit, and all we're left to talk about is half-life and applications, and then that's the whole unit. So, and we'll do a lab also. So that's the story. Use table N and table O on page 4 if you need help, and that's about it. Thank you so much.